In this chapter, we're going to talk about polynomial equations and factoring. In 7.1 specifically, we are going to talk about adding and subtracting polynomials. Before we talk about how to do that, we're going to kind of go over some key words. So the first word we're going to talk about is the word monomial. A monomial is a number, variable, a variable, or a product of a number and variable. The way I like to think about a monomial, when you see that word mono means one. So it's kind of like when there's a one-term piece. So let me explain to you what a one-term piece is. An example of that would be 7x. An example of that would be 7x to the third. An example of that would just be the number 5. Could be 8x squared y to the fifth. But what it is that they are all kind of one piece or one term. So this will probably make a little bit more sense when we talk about what a binomial or trinomial is. So when you think of the word binomial, that's when you have two terms. Like bi as in bicycle, two wheels, binomial is two terms. So the way you separate terms is with a plus or a minus. So an example of a binomial would be 7x squared plus 4. There are two pieces to it that cannot be put together. Another example might be 7x to the fourth, y to the fifth, minus 3x squared y. So it doesn't matter how many pieces are in a term as long as they're all multiplied. But the minute you have a plus or minus, it separates into another term. So this would be 1, 2 terms. So then you go to trinomial, and when you think of the word tri, like tricycle, you think of 3 wheels. So a trinomial is 3 terms. So an example of that might be 4x squared minus 3x plus 7. 3 different terms that cannot be put together. 6x to the fourth, y to the fifth, minus 7x squared y plus 8. 3 different terms that cannot be put together. That is a trinomial. So a polynomial is actually kind of all of these and more. So a polynomial is a monomial or the sum of a bunch of monomials. So even though these 3 have specific names, everything bigger than a trinomial is just called a polynomial. So say it had 4 terms. That would be called a polynomial. It does not have a specific name after a trinomial. So the degree of a monomial or polynomial is the greatest degree of its terms. Now this can be a little bit tricky because when you think of a term, you have to think of the entire thing. So if we look at this example, you kind of look at all of the powers on all of your variables, and you say, okay, that's a power of 3, a power of 2, this is actually a power of 1, and this actually has a power of 0, because anything to the 0 is the number 1, so it doesn't really exist. And you look and say, okay, what's my biggest one? 3 is, so that would be my degree. So this would have a degree of 3. This one right here, 7x squared plus 4, would have a degree of 2. It gets a little bit trickier when there's more than one variable in a term. So if you take a look at this one, you have to kind of look at the entire powers on all the variables. So this power would be 9. This power right here would be 3. Because 9 is bigger than 3, my degree is 9. We will practice that coming up in just a minute. Standard form is when you write a polynomial from highest power or degree to lowest power. So for example, if you look at this one, do you see how the powers naturally go down 3, 2, 1, and then nothing? That is in standard form. If it's not in standard form, This would be something that would be not in standard form, but you can always rewrite it to get it in standard form. My highest power is 5. I would put that piece first. Then my next highest power would be 3, and then I keep my constant or my 7 at the end. The leading coefficient is the number in front of the term that has the degree. So for example, if you look at this example right here, your degree would be 5, so the leading coefficient would be -5, the number out front. This example, your degree would be 3, your leading coefficient would be 4. So for our next example, we're going to do just find the degree. So to find the degree, if you notice these are all monomials, one chunkers, you just take a look at the power. So the only variable here is x, my power is 1, that makes my degree 1. Over here, because we have multiple variables, you have to add all of the powers together. And if there's nothing written, it's a power of 1. So when I add 2 and 3 and 1, my degree is 6. On this one, I have my 1 and 3, so my degree will be 4. And remember, I'm only looking at the powers of the variables. And then if it's a constant, every constant really has an x to the 0 at the end, which is really just the number 1, so it doesn't change it. So that degree would be 0. All right, so here we go on our next examples. We are going to write in standard form, identify the degree, the leading coefficient, and then classify it by its number of terms. So our first example in standard form, I'm going to start with my highest power, which is my squared, so 3x squared. Then my x piece, plus x, and then plus 5. That is standard form. My degree is my highest power, which is 2. My leading coefficient is the number in front of that, which is 3. And because this has 3 terms, he is a trinomial. On my next example, because there's only one term, I can just rewrite that one term to stay in standard form. My degree is my power, which would be 1. My leading coefficient is the number out front, which is square root of 5, and because he is a one term, he is a monomial. On my next example, I'm going to put the 6x to the 8th first, because 8 is bigger than 5. Then I'm going to add plus 3x to the 5th. My degree is my highest power, which is 8. My leading coefficient is 6. Because he has 2 terms, he is a binomial. In my next example, my highest power is 4. Then I have an f squared minus 2f as I work my powers all the way down. My degree is 4. If there's no number out front, it's assumed there's a 1 there, so my leading coefficient is 1. He has 3 terms, so he is a trinomial. On my next example, if you will notice, this has a power of 2, this has a power of 2, and this actually also has a power of 2. If you have more than one of the same powers as your degree, you may put them in any order. A lot of times you will see them written alphabetically. So I'm going to start with my negative 9a squared. Then I'm going to go plus 2ab plus 4b squared. Depending on what order you put this one in, your degree and leading coefficient may be different than mine. The degree should all be 2, because no matter what order you put it in, it will be 2. But depending on what you put first, it might change your leading coefficient. My leading coefficient is negative 9. There are 3 terms, so he is a trinomial. And then on the last one, my highest power here is 3, power of 1. My constant always goes at the end, and this also has a power of 3. So I'm going to start with 4m to the 3rd. Plus 5mn squared minus 2m plus 7. In the first two, you could have switched as well. My degree is 3. My leading coefficient is 4. Because he has more than 3 terms, he is called a polynomial. On the next page, we are going to talk about adding and subtracting polynomials. So if you take a look at your first example, you will notice that there's a plus inside. And the other thing you will notice is that there's not a number out front here nor any number out front there. If there's just a plus here without any numbers, all you do is you just add your like terms. So if you notice, both of those two pieces have x's, so I just combine them. Negative 4 plus 6 is a 2x. And then I take my other like terms. 9 minus 14 is a negative 5. On my next example, I'm again going to combine my like terms. So I'm going to start with my x squareds. So x squared and negative x squared cancel each other out. Then I'm going to do my x's. 3x and 6x is 9x. And then I'm going to take a look at my numbers. 5 minus 4 is a positive 1. You can only combine if there's a plus in between and there's no numbers out front. So my last example is the same. I'm going to put it in standard form, so I'm going to start with my highest power. So 3 minus 2 is 1t to the third. Then I'm going to, those are done, so then I'm going to take a look at my squareds. 2t squared and a 1t squared is a 3t squared. And then I'm going to look at my next t piece, which is a 7t, and then a minus 3. I cannot put these two together because one has a t and one doesn't. Now, it's a little bit different if there's a minus inside. If there's a minus inside, it's like that there's a negative 1 minus 1 out front to distribute. So you keep the g minus 4, but you have to distribute that negative through. So this negative makes the 3g a negative, but then it turns this negative and this negative make the 6 a positive because two negatives make a plus. Once I do that, then I can combine my like terms again. 1g minus 3g is a negative 2g. Negative 4 plus 6 is a plus 2, and there's my final answer. So in this case, there's nothing out front here, so I'm just going to rewrite that first part. And if it helps, you can put a little 1 in front of that x squared, that negative. Over here, I'm going to distribute the negative. This negative and that negative make that a positive 3x squared. This negative and that negative make that a plus 1x. This negative and that negative make that a plus 8. Now I'm going to combine my like terms. I'm going to start with my squareds. Negative 1 plus 3 is 2x squared. There's nothing to put with that 1x, so I'm just going to write him down. And then my last step would be to combine my two numbers at the end. Negative 5 plus 8 is a positive 3. On my next example, I'm going to rewrite the first part because there's nothing out front there, and if it helps to put a 1 there. Then I'm going to distribute the negative. Minus 5k to the third, minus 7k, and then this negative and that negative make that a plus 3k squared. I'm going to write it in standard form, so I'm going to start with my k to the thirds. 6 minus 5 is a 1k to the third, or just k to the third. Next, I have some k squareds. I have 1 and 3 is 4k squared. Next, I have a negative 7k, which has nothing to combine, so I just write down negative 7k, and then my last number is a minus 4.